All right, hello everyone. This video is for a question like one of the Math Excel questions. I believe it was day 2. It was one of the last ones on the Math Excel assignment. So I'm doing a question that's very, very similar to what was on Math Excel. This example is from the book. The question reads, an aircraft is flying at a constant speed of 500 miles per hour due south. And there's a jet stream um, that's moving at a constant speed of 80 miles per hour in the northeasterly direction. Okay, so what I did was, if you look on the picture to the left, the red vector is um, the airplane, and then the blue is the jet stream. All right, the green is the path and the vector of where the plane is actually going. All right, because that's the resulting vector when you add the red and the blue. Okay, I'm going to label the red one as v sub a, vector of the airplane. The blue one we will call v sub w for the wind. And then the green one, we're going to call this one v sub g because it's relative to the ground. Okay. Now, for the red one, this vector is, since it's just due south, using the component form, it's negative 500j, right? Or, technically, this comes from 0I plus negative 500j. All right? So we're going to keep that in mind. This actually is going to be useful in one of the other steps. Okay? Then for the wind, right? Now, when it says the wind is northeasterly, right? It doesn't give us the degrees, but it's northeast, which is implying that this is a 45-degree angle. And if you watch my other video, we talked about how we can get a vector component form from the unit circle, right? So if this is a 45-degree angle, I know that the coordinate in quadrant 1 of 45 degrees is root 2 over 2, comma, root 2 over 2. Okay? What that translates to, in terms of vector component form, is this is actually root 2 over 2i plus root 2 over 2j, right? Just like how the red one, hopefully you can see the mouse that I'm circling here, right? Just like for the red one, when it's due south, we can write it as a vector component form as 0I plus negative 500j. The jet stream, we can write it as root 2 over 2i plus root 2 over 2j. Now the thing is, we know that it's going at a speed of 80, so we have to multiply that by 80. Okay, so this comes out to be, this is actually 40 root 2i plus 40 root 2j. Okay, now with the book, you can leave it like that if you want. What the book does is it takes out a factor of 40 root 2 and it writes it as I plus j. Okay, doesn't matter actually which one you use. All right. Okay, so now at this point we have enough information to figure out part of v sub g. Okay, so we know that v sub g, right, I'm going to do this. All right, this vector, we said, is the result of adding v sub a and v sub w, right? You're going to add the vectors of the airplane and the vector of the jet stream, okay? So we know that v sub a is, now if you want to use just negative 500j, you can, all right? I'll color code it here, negative 500j plus we said VW was 40 root 2I plus 40 root 2J. Okay, so when we combine like terms, well, in some sense, we're just going to simply move things around, right? Because we cannot actually add we can't actually add the negative 500 and the 40 root 2, but we are going to write them together, right? So this is 40 root 2I, okay, plus, and I guess I'll kind of drag it out here a little bit. This would be 40 root 2J minus 500J. And so what I'm going to do is I'm actually going to write it like this. 40 root 2I plus parentheses 40 root 2 minus 500 and then J on the outside like that, right? Because remember, a vector can be written as AI plus BJ like that, right? And so the 40 root 2 is actually our A, and all of this here in parentheses, that's your B. Okay, so that's how I'm going to write it here. So I want to write it like that because that's going to help me figure out what the actual speed is. Now, if you, over here to the right, if let's say that represents, we know, some vector, right? But the actual speed, right, is given by the magnitude, okay, which is the square root of a squared plus b squared, okay? And so when I use that over here, right, my actual speed, or the magnitude of v sub g, that's what I need, is going to be the square root of all of this. Right? All of this squared. Right? And so you can, at this point, you can go to your calculator, right? You work this all out, okay? When you do that, your actual speed here, and hopefully you enter things correctly, and I suggest that you actually try it on your own, all right? Get familiar with doing these on the calculator, and you should get, this should have been approximate, around 447 miles per hour. Okay, so that's the actual speed here of the airplane relative to the ground. Okay, so again, that's that was the actual speed, right? So now what we need is actually we need to know the direction, right? I'm going to try and squeeze that in here, okay? And the formula there is the cosine of theta is equal to the dot product of two vectors. So we're going to do, and let me go back actually. Go look at the drawing again, and the angle that we need is right here, theta, right? And when we do directions, remember we always base it off of the y-axis, and so from the y-axis we're swinging out to the green. Okay, so going back over to the right, the formula here, cosine theta, is equal to Vg times Va, right? The dot product between those two vectors over, okay, over the magnitude of each of those. Oops, sorry. Let me erase that. Okay, so when we do the dot product, which was, I know for some of you it might seem like it was a long time ago, when we multiply Vg times Va, remember you're multiplying the I components, and then you're adding, and then you're multiplying the J components, and then you're adding them together, all right? Now this is the reason, if you look over here to the left, I'm going to circle this. Remember for VA, right, your I component is 0, and then your j component is negative 500. So when if I were to actually drag this all out, right, VG we know was, I'm going to circle this right here, right? This was VG, right? VA was right here, over here on the left, okay? And so when I do the dot product in the numerator, it's actually 0 times 40 root 2. Those are the coefficients for the i's, plus, right, negative 500 times 40 root 2 minus 500. Okay, so this represents the coefficients for the j's. Okay, so now obviously this over here where I'm circling, this is just 0. Okay, and then down here is going to be the magnitude. Here, I'll just rewrite this for now. The magnitude of VG times the magnitude of VA. Okay. In the numerator, I'm going to clean that up a little bit because, like I said, that's just 0. That goes away. Okay, so that's negative 500 times 40 root 2 minus 500 over, now the magnitude of VG, we already figured out. That was right here, right? That was 447, or we estimated it. We rounded it, okay? VA over here, where I'm circling, right? VA, you have to do the same thing, you know, with the 0i plus negative 500j, right? But that turns out to be 500. Okay. So when you do all of that, all right, this turns out to be rounded 0.9920. But remember, it's the cosine of theta is equal to 0.9920. And when you do the inverse on your calculator, make sure you're in degree mode. You should get about 7.3 degrees. Okay, 7.3 degrees. Now, to officially write that, if you go here to the left, remember when we write bearing, it's always the north-south first, and then east and west. So since this is in the southeast direction, your theta is south, is south 7.3 degrees east. Okay, I hope that was helpful, and yeah, let me know if you have any questions.